Alright, here we go. Who can use their psychic powers and tell me what it is we're learning about today? You guys know how this works. You don't have to be all fancy with it. What are we learning today? A normal curve. So today we're talking about the normal curve. And we're going to figure out what the heck that's talking about here in just a second. The normal curve. Now, before we jump into what the normal curve is, let me go ahead and reiterate that example that we just started with. Example 1. What is the probability that a student, I mean, it's up to you. You can abbreviate it if you want. A student at Tucker School is less than 50 inches tall. Now, we had a couple guesses. We got group A that says there's a 10% chance it'll be less than 50 inches tall. Group B says you can't tell, it's undefined. Group F and E says 45% chance, and group G says 36% chance. Would it help you at all if I told you the average height? Yeah. Would that help you come up with your guess? Some of you guys smelled that something was up, and you're right, because I don't tell you anything about Tucker School. What I failed to mention was that Tucker School was actually an elementary school. So the average height the average height is 39 inches. Would that have affected your percentages a little bit? If I tell you the average height is 39 inches and I want to know how many people are less than 50 inches tall, you can guess that it's at least 50%, right? Because if the average is 39, then you would expect that half the people would be below 39 and half the people would be above it. So if I had given you the average, then you probably would have been a little better off. Now, you still might not have gotten it exactly right unless I gave you another piece of information. If I tell you the standard deviation, oh, I made this way harder than it's gotta be. Okay, I'm gonna pull in the board. You guys ready? I'm gonna change it to 38 inches. You're gonna, I know the difference. You'll see it in a second. And I'm gonna make the standard deviation is 6. All right. Whether or not you realize it, now you have enough information to make a reasonable guess. Everything else before this, you guys had no idea what kind of school I was talking about. You didn't have enough information to really be accurate here. But now you have enough information to make an educated guess here. So here's the way it works. First off, you guys know what average means, right? How do you find the average of something? Add it all up. Divide by how many you got. What's another name for average? Starts with the M? Mean, right? So when I say average, really the technical term we should be using is the mean. And it has a symbol that we're going to be using in mathematics. For this class, it looks something called mu. All right? It looks like a U with a tail in the front. Okay? It's actually Greek. It's pronounced like M.
It looks like something, I don't know.
Yeah, I don't remember what it uppercase to be like. It's a Greek letter. It's basically like the Greek M, right? So mean has a fancy symbol, mu. Sometimes you'll also see textbooks call it X bar. Like it's an X with a line over the top of it. All right, it all means the same thing. It just means the average. All right, The mean is like the average. Standard deviation also has a funky symbol. It's a lowercase sigma. We've seen uppercase sigma. That was like with the summation notation, you had like the crooked E. But standard deviation, you can also use this little lowercase guy. Now we know what average is, but anyone have any idea what a standard deviation is? Standard deviation goes with something like this. Let's make a little vocabulary box. Standard deviation is basically telling you the average distance from the mean. I'm going to go into a little more explanation. It's the average distance from the mean. So in general, you can make the statement that the bigger the standard deviation is, means the wider spread your data is. Okay? The bigger your standard deviation means you're going to have a wider spread of data. So that's what I'm talking about when I say standard deviation. Now I'm going to give you guys a little thought bubble here. All right, and remember that the standard deviation symbol is sigma. All right. So now real quick, once you've got that down, just put your pencils down because I want to give you an explanation on what standard deviation is. You don't need to know this explanation to solve the problem, but it helps to understand why we're doing what we're doing. All right, so once you got it down, just put your pencils down. All I want to do is listen. Check this out. I got 2 different basketball courts that I go to. Okay? Here's court A, and I went to it last week. On Monday, 15 people showed up. On Tuesday, 20 people showed up. On Wednesday, 25 people showed up. On Thursday, 15 people showed up. Friday, Saturday, Sunday. Now, you can find the mean here, right? You could add them all up and divide by, what would we be dividing by this time? By 7, right? I got 1, 2, 3, 4, 5, 6, 7 days at the court. There's 15 plus 15 plus 15, blah, 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 blah. You can add them all up and divide by 7. Or you can just look at the daggone thing. What does it look like is the average number of people that would show up on a given day? 20, because it's kind of balanced around 20. Your mean is kind of like your balancing point. So just by visualizing this thing, you can see that your mean would be 20. All right, so that's court A. Let me tell you about court B. Court B, there was 10. That makes sense. So, all right. On court B, on Monday, there was 10 people. Then on Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday. All right? Again, just by eyeballing it, can you tell me what the mean is going to be? The mean is still 20. Now, are these the same court? No. I mean, depending on your style, I would probably rather go to court A because it's more consistent, right? It's less spread out. Court B is more spread out. Now, what we're just saying about standard deviation is what you can expect is that the standard deviation of court A is going to be less than the standard deviation at court B. The bigger your standard deviation, the more spread out you are. Now, you will never actually have to calculate the standard deviation. If you did, the calculator can do it for you. To be honest, the real formula is very complicated. It's got like square roots and sigma notation and all this kind of mess. But you don't have to do all that. You never have to do all that. They're either going to give you the standard deviation or they're going to give you an easy way to find it. But just so you know how you could approximate it, here's the way it works, right? You know this is the mean, 20. Remember we said standard deviation is the average distance from the mean. So in order to find the average distance from the mean, I need to find all the distances for each data point from the mean. Well, how far is 15 from 20? 5. There's another 15, so that's also 5. These are all on 20, so 20 is 0 away from 20, right? Over here, 25 is, again, 5 away from 20, same down here. So if you wanted to find the standard deviation about, you could add up all your distances, which in this case is 20, and really, and I'm going to approximate this because it's not, the actual standard deviation formula is much more complicated than that. So take 20 and divide by all 7 points. So here your average deviation, or your standard deviation, is going to be like 2, almost 3, something, right? It's like 2 point, I don't know what that would be, 9 something? No, what is it? Let's figure it out. 2.86, whatever, yeah. Over here, standard deviation. How far is 10 away from 20? 10, 5, 5, 10. Add them all up, and I got 30. I'm still dividing by 7 because there's 7 different pieces. And what does that end up giving you? 4.2, not 1.6, right? So here you can see, the more spread out you get, the more distance you're going to have from the mean. So that's going to make a bigger standard deviation. Okay? I just need you guys to understand that standard deviation is telling you how spread out your data is. You're never going to have to actually calculate it, but I need you to understand what it's kind of hinting at. Right? Okay, that's actually a good sound. So let me